So in the beginning, I think.
Take this one. Yeah.
Thank you, Peter, for the introduction. So in the beginning, I would like to make a very quick demo what Primo actually looks like so that you have a better idea for our talk. So I will pass the microphone to Rishi, who will be doing the demo from his laptop.
Yeah, so Primo as a tool was presented during Tugboat 2023. So just to give you a perspective as to what the tool is, we will start off with just a quick demo of the tool so that you will understand things better, because Tan and Jan would be explaining it from a developer perspective. So until you understand what the tool is, understanding other things would be difficult. So we'll start off with it. So Primo is basically an authoring and proofing solution. So it is tuned for mostly academic journals. So once the tool starts, you will be able to see the specific panel on, as you see on screen, where you have the entire navigation, the author related information, the front matter information, the back matter information, all of that presented on the tool itself. So that information will be there on the tool, would be available for the authors to edit. Similarly, the other navigation panels that you have are the entire editor of the tool, where the entire academic content will be shown, which is at the center. And the most important part of this tool is creating the PDF. So when you create the PDF, it uses the tech engine to produce the PDF. So once you compile the document, it immediately produces a PDF output. And the PDF output will be shown in the panel over here. Similarly, the other benefits of the application are the track changes, posting queries to the author. All of that can be done from a single interface without having to go through multiple email exchanges. So these things have all been integrated into the tool. And most importantly, the tool works on a DTD. As of now, it is specifically created for the Elsevier DTD. And in the future, other DTDs will be supported. And if you see over here, once a compilation happens, the PDF is generated. Tech engine generates the PDF. Yeah, there are single column and double column options available in the tool. So with the just a change of a flag, you can convert the document from a single column to a document to a double column. So the compilation happens in the background and the PDF is displayed. So, and more importantly, one of the key features of the tool is the text pagination engine, which is built into the Vaněk tool itself. So you have an option of injecting pagination commands, so that instead of going back to the text source code, you could directly do the pagination from within the Vaněk editor. Then the tool is completely collaborative, so multiple users could work on the same document at the same time. And the other, the renumbering, in case if you add any, the counter renumbering happens automatically as you see in tech. So this is the first tool which supports that particular option, wherein in case if you remove an equation or a table, the entire, the counters are reset automatically in the Vaněk editor as well as in the XML. So Rishi is showing that option. So now I hand over the mic to Han to present it from a developer's perspective.
Yeah. Thank you for the quick demo. So it was quite overwhelming to see everything on the screen, so I would like to simplify it. For tech user, it mostly, what is Primo at the core is an online XML editor, and that's it. It's simplified. So they, of course, more to that. And in order to understand why Primo was created, we need to understand that, I would like to say that for most users, when they prepare some documentation and then they get a PDF that they are happy with, that's the end of the story. But if you are an author who would like to submit your article to some journal, at some publisher, then it's just halfway. So the article, before it can be published, it must be changed to meet the requirements of the publisher. It must be converted to XML because that's the format that most publishers require, and so on. So the article that was submitted, it rarely ends up in the original form, but it must go through many changes. And during that process, often it happens that the changes are not desired by the author. So it can happen that the typesetter makes some change, and then the author sees it and says, oh, it's not what I meant. I want it back. And then he makes a change, and the typesetter says, okay, but it's not allowed by the standard. So we need to go forward and back, forward, back. So that process used to be very lengthy in the past. It go via email, and then recently there are some tools to make it easier, but there's still a gap in this area. And Primo was designed to fit this gap to make it efficient. And another thing is, from the XML-based workflow, creating high-quality PDF with math is very difficult. And Primo also tries to fit this gap as well. But it's quite a lot of talking, but we are often asked by our friends and our family, what are you guys doing? And we say, okay, we are working on a software product called Primo, and what does it do? And now it gets interesting because I cannot say anything about XML or academic publishing, so that's what I come up with. So Primo is very much or very similar like Google Docs, but it's designed for scientific publishing. And usually that answers the question. If somebody doesn't know what is Google Docs, then the further step would be it's similar to Microsoft Word, but on the cloud. And if it does not answer the question, then I got stuck, but let's stop here. And the input for Primo is so-called XML datasets. That's XML plus the figures and the metadata and so on. And Primo support both structural editing. That means that you can edit the structure of the document, or you can use a WYSIWYG editing, just like in Google Docs or Microsoft Word. So we try to make it similar to the well-known tools so that the user will be comfortable when they use it. And another very important goal is to make it efficient. So we want to minimize the communication between the author and the publisher before the article gets published. And another very important goal, but I forgot to write here, is that we try to make it easy for the author to see the PDF as close as possible to the final version. Because what the author submits usually is not what he sees finally in the print. And there's a gap, and we try to minimize that gap. So here are a few screenshots. So the first one is, let's say, for the author. And the second one is, let's say, for the editor to check the formatting and so on. So Rishi has done a good job, so I think we can skip these slides. So this is the overview how it works from a high level. So we have a lot of clients. The clients connect in web browser to Primo server, and then Primo server has a bunch of so-called remote worker server, which does the heavy tasks like PDF compilation or XML validation. Yeah, why we are doing that? Because we want to make the Primo server efficient. So that's this way we can scale the Primo server very quickly. If there are more demand, we just add more remote worker server, and that's it. So here's quick overview of what happens. The technology stack we use is heavily based on Scala. Almost everything is written in Scala. So the back end, the front end, even the CSS is written in Scala, and even some script for deployment is also written in Scala because Jan is very comfortable with Scala, and we use IntelliJ IDEA as the IDEA. There are a few other tools that we don't need to go into detail. At the front end, we use a VDL. One quick question. Who here knows about React from Facebook? Okay, 1, 2. Yes, so VDL is our own framework for developing UI components. So it's similar to React, but it's written by ourselves in Scala and transpiled to JavaScript. And then CSS is also written to Scala and translated to so-called pre-CSS, which is CSS with CSS classes from Tailwind CSS. Maybe you know about Tailwind if you are doing some front-end development. And for the font, we use the sticks. Actually, it sticks to like Vincent for his class. And for the UI, we use sources font. And for the fixed width, we use Korean Prime. And for the icon, we use the so-called remix icons, which is a little bit less known, but for us, it is a perfect fit. And when there are some icons that we need, then we make it by ourselves in Inkscape. So this is a quick overview of the code base size. So I think it's about that, and I will pass to Jan to continue from here.
You speak about modules.
I think it's better for you. You do that. Yeah.
So hello. Do we have a pointer? So here I can make a next slide, right? Okay, so so Primo, I thought actually that Tan would be speaking about this. So Primo has many modules, and the advantage of Scala is that not only it can compile to JVM, it also compiles to JavaScript. And this is very good for us because we have some pieces of code in each module which we want to share between the JVM and the JavaScript. So each module basically has 3 parts: for JVM, for JavaScript, and the shared. And the shared with JVM is compiled to JVM, and shared with JS is compiled to JavaScript. The modules, we have several modules. I can quickly go over them. We have the editor, which is the most important. Then we have the drive, which is like a Google Drive application. Then we have the admin for our administrator who can add users, give rights to users, see the exceptions which happen, and so on. And the others are not that important. This is also a detail. Now I'm getting to the document model, and actually the purpose of this is that I want to focus on one particular aspect of Primo, which is the real-time collaboration. And in order to get there, I need to present some details about the document. So when the document is loaded to the memory, it is represented as a tree of nodes. It is very easily for you just visualize a tree of nodes. And each node has a unique ID. We can quickly get from the ID to the node. This is more like a little bit of detail. From the point of containment of or how the nodes reference each other, we can categorize the nodes into 4 subtypes, and the first subtype, which we call node with subnodes, it is a node which can have multiple dynamic subnodes. So you can imagine internally it contains an array of its child nodes. This is used to represent nodes in the DTD which are repetitive. For example, in DTD you can have something like para and then this asterisk mark which signifies the repetition. So such nodes are represented as node with subnodes. Then we have a node with subnode, which is a node who can have 1 or 0 subnode. This is used for representing optional nodes. And then we have a node which we call node with children, which has a fixed set of pre-created children. You can imagine this is just a interface, as we would say in Java. In Scala we call this trait. And the concrete subclass of this node with children then specifies what are the fixed children. This is used very often because the DTD specifies that this node has these children and this node has these children, and this is statically given. And then we have a special node which holds the text, just for completeness. Nodes have attributes which we call facets. The attribute value is something immutable. You can only set it as an atomic operation, set or unset. Obviously. Yes. Initially, we tried to not tie Primo to a specific DTD, but we failed at that time because the DTD of the publisher. DTD of the publisher has specific set of nodes, and there is a specific extensive functionality. So we could not do this by having a generic set of nodes. If we would need to port, it would be to some other DTD. It would be possible, but it would be some work. The collaboration would remain unchanged. So now we are getting to something related to the client. The document model supports observation. This means that you can register an observer to whatever node you wish, and when the node changes, the observer fires, and this is used to update the user interface when the document model changes. We also have so-called deep change observation, which is used when which works that anything what changes below the node would trigger the deep change observer. Important is to have in mind that now we have the data model and we have the user interface, and as soon as the data model changes, the user interface is updated. This is done through the observers. So there is nothing else about it. But important is to know document changes, UI updated. Yeah. when the user is making his changes, we represent the changes as operations. Example is like insert, delete, or set facet. You can imagine the operations as a small data classes which we send to and from server, and we do this asynchronously so that it does not interfere with users editing the document. And even when the user is not doing any changes, the client fetches the operations from the server from other collaborators. This is just to give you a quick idea how such an operation looks like. So, for example, we have the insert. I omitted the type annotations. So the insert operation contains the ID of the node at which we need to insert something. Then it contains the offset where it is supposed to be inserted, and the cargo, which can be, let's say, the characters or array of subnodes. Delete is somewhat similar. It may be surprising for you that you can see in the delete that there is also the cargo. This is because once you want to delete, you don't need to specify what you want to delete, but it is there because the operations are designed so that we can invert them. And this is used for to implement undo. So we need to very precisely be able to invert any operation. Yes. This picture depicts the simple situation where we have only one editor. Yes. You can, as the editor is making some changes, the operations are sent to the server, and here on the server the operation is applied to the model, and the model is changed on the server, and then these operations, the confirmed operations, are sent back to the client. When we have multiple collaborators, the situation is little more complicated, because let's say that you are the editor too, and you have made this operation. You send this operation to the server, but in the meantime, other users did these two operations, which you don't know yet about, but it is waiting for you to be fetched on the server. So, but before we apply these operations which you are sending on the model, it needs to be rebased against these two operations because they are already applied to the server document model. So what does the rebasing mean? So if the operations are on two separate nodes, then there is no rebasing. There's no problem at all. But if the operations modify the same node, then you can imagine that, for example, you are inserting some text at offset 20, and somebody before you inserted a text at offset, let's say 10, and it means that the offset needs to be shifted so that it is inserted at correct position. It's not really complicated. But and then when the operation is rebased and applied, it is queued for all other collaborators here so that they can fetch it. And here it is also sent back. So these are the two operations from other people. This is your operation, and they all go back to you, to the client. So this is the server situation. It is actually more easy than than the client situation to which we get now. I will skip this. I will come back to the text. So this is the situation on the client. Let's say you've made some change, which is then sent to the server, and then your change is coming back, and these are the two operations from other people. They are coming back, but in the meantime, you have managed to make another two operations. It is not that likely, but it's possible, it can happen. And these new operations which you have done, they have not yet been sent to the server, but they have already been applied to the document model, and the UI already reflected it. So here is the recapitulation, that we have these incoming changes from the server, the accepted changes. Then we have our own changes, some of them just sent and received from the server, also accepted. And then we have the changes which we have just done, but not yet sent to the server. But they are already applied to the document model and already reflected in the view. So how do we apply the incoming changes from the server, which are confirmed while we have already applied the new changes which the server doesn't know yet? So this problem, there are different ways to solve it, and the way we solve it is the technique which we call three-layer or three layers. And it basically means that the document model is internally triplicated, that the document model is a tree, but we have like three layers, three separate layers in the model. The first layer, the layer 0, is the main layer which the UI observes and updates the document. The second layer is the so-called server layer, which holds the latest server version of the document. So it holds the latest confirmed server version. And then we have a temporary layer, which I will explain. What we can do with these layers is that we can very quickly transfer one layer to another layer. So for example, I can say now transfer from layer 1 to layer 0, and quickly the document model will be completely changed in the layer 0 to layer 1, and the UI observers will fire and update the view. And here is how it works, how it solves that problem we had. So I will come back to the image. So when these changes from the server come, then we don't apply them to the main layer. We apply them to the layer 1, to the server layer. Then we transfer the server layer to the temporary layer. They are now identical. Then we apply these operations on the temporary layer. And finally, we transfer the temporary layer to the main layer. And the observers are fired and UI is updated. So here it is in words. Yes, that is all. I hope I made it clear. So thank you for your attention.
Thank you, Jan. We have 7 minutes for discussion, questions. No. Yeah?
Thanks for the talk. I would be interested in the server technology. Are you using Remix or Node.js?
No, we use Undertow web server, and we use SQLite for the database, and we use Lucene for full text index. And that is all, I think, the main libraries.
And so how did you come to those Remix icons?
Oh, this is a client thing, and Tan would then say it better, the Remix icons.
Yes, because in Primo we need a lot of icons. So we decided to choose the font icons way to make it simple for us. And after trying a few libraries, then we settled down on the remix icons. So which is not very well known, but it's a good fit for us. So we have tried out some, and we have a few very well known libraries which has very large collection of icons, but they look they doesn't fit into our team.
I have a question from YouTube chat and a question from me. The question from YouTube, from Luigi Scarsa. Is it possible to use LuaTech as an alternative engine, or are there performance issues?
Is it possible to use LuaTech?
Or LuaTech?
What?
Whether it is possible to use LuaTech?
LuaTech. Okay, so we use LuaTech in the beginning, and then we switch to ZLaTeX at some point later for the performance. Mm-hmm. We don't use PDF LaTeX because we need Unicode.
Yes.
Yes, but internally we have a TextFolio farm which is used for the user, and there we use PDF LaTeX for performance because we don't need a perfect PDF. But in this case, we need the best possible PDF from the XML, and for that reason we use ZLaTeX.
Mm-hmm. Great. And the question from myself. One of my biggest problems with Google Docs is that it's there. Google has it. I don't have my own copy. I can archive and so on. Can a user download their file from your site, make their own copy, and so on? So basically, is it possible for users to have their private collections of their work?
The user can download their data at any time they want, but they get the XML data set.
XML, okay.
Yes.
Users have XML. Thank you.
So
you can, as Stan said, you can always download the XML back, but you will lose some information at the moment because in Primo, when we represent track changes, these we cannot export to XML.
Nelson?
In the earlier slides where you had the Primo desktop showing, where you had a text editor window on one side and the PDF for typeset output displayed, is there a way for the person doing the typing in the editor to see the XML view rather than the sort of almost typeset view? The reason I thought this, if you're introducing a new DTD, there might be problems, and you have to say, well, how did this get translated? So is it then possible for the XML to be exposed?
Yes, it is possible in a certain way. We have a tab there on the left panel, which is called structure, and there you directly see the tree structure of the nodes, so which it directly corresponds to XML, right? You just don't see XML, but you really see a tree structure. I really like this view, but nobody else likes it, you know.
Actually, during the testing phase, then users are scared when they see this structure view because it means nothing to them. A huge tree from the XML, and that's it. And for a normal user, it doesn't make any sense. So it's there if you want it, but it's not mandatory.
I have another question from YouTube. To tell the truth, I'm not sure I understand the terms here, but here you are. M-scripting allows you to compile a C program in WASM, ZTech.js. Does it make sense to consider using a PDF engine in WASM?
I don't know either.
So we are using, we're not transcompiling and creating the Java version of JavaScript version on the web, because the tech engines that we have to use for our production systems should confirm properly and produce the correct output. Sometimes when you use the JavaScript version using Nscriptum, it might not provide us the right output.
Yes, another reason is that by doing the PDF compilation on server, then we are able to scale it. So if there are more compilation, then we can add more server to cope up with the demand. If we are doing it in the browser, then it might work, it might not, but I think it's not worth the effort.
Yeah.
What do you use to convert to TeX, and to which TeX do you convert? And can the user download the created TeX?
We have two ways to create the TeX. The one way is directly from our data model that we export the TeX. This was done by Tan. And then the other way is that we export to XML, and then we use XSL transformation to create the TeX. This is currently used because we have we sometimes need some tweaks, which one of us, Apu, is using. But I would really like to get into state where we can have this eliminated and where we can just directly create TeX from the data model through a visitor pattern. It's not that complicated.
Yes, LaTeX with the Elsevier classifier. Yeah.
It's a proprietary classifier.
And yeah, the exceptions route is like for exceptions that we don't support yet in Primo, but we expect that over the time, the direct TeX export from Primo will be usable for most cases because it's very fast. It's instantly. It doesn't take any time, and the other row it takes much longer, and it should be used just for, let's say, for exceptions.
It is also some layer of complexity if we have these informations encoded in XSL. So if we could avoid that, that would be better.
Thank you for the talk. A quick question. This is a proofing tool for authors, between authors and publishers. By the time the article arrives as a publisher, even before it gets accepted, would have been authored by the author already. So do you have tools for the publisher to be able to ingest the author file upon acceptance? Because the article is not going to start in your tool, right? So the author will write it in TeX or in Word or in some the favorite sort of flavor of word processors.
Yes, currently when the author writes the document in TeX or in Word, it goes through some pre-processing, and then the document, which is a zip file with main XML and some other files, is imported to Primo, right? That is the current way, because authors are not authoring in it. And once it is in Primo, it follows a certain workflow, right? So, for example, the document is can be is going from one stage to another. Okay, so it goes to typesetter, then the typesetter makes some changes, and then he submits it to the author back, and he's accepting or rejecting some other changes, and then it goes to another stage, and then it can go back to author. And in these stages, different people have different rights to do changes or not to do changes. So it is not like that, like in Google Docs you are just editing and there is only one state, we have this sequence of state in the workflow.
Okay. So as of now, Primo has not gone into the phase of complete as an authoring tool. So in the future iterations, this should become an authoring tool as such. So just like an author is submitting their files as a LaTeX file or a text file, our plan is to have this tool itself as an authoring platform wherein a Primo output file will be submitted to the publishers. So once that is submitted, just with the hit of a button, the PDF, XML are all done because the underlying document model is completely using XML. So that's something in the future. And integration of tools like from tech to loading it into Primo or from doc to loading it to Primo, something that we have plans in the future also.
Thank you all for Jan and Tan for presenting and all you for coming and questioning. Let's applaud the developments of Primo.